Yo, yo, let's finish this thing off, shall we? We're going to end our lesson on adding and subtracting rational expressions, and we're going to get crazy. So let's do a quick recap. And if you haven't seen the first video, you may want to do yourself a favor and watch that before getting into this, because you're going to blow your mind. So remember what we talked about previously, what addition is, gathering together, but it's the same unit of measure. If it's not the same unit of measure, we have to find common denominators so we can convert into the same unit of measure. So, and how we do that, we multiply by a clever 1, and we get our same denominator or same unit of measure. And we went through a couple of examples of that stuff. And we had basic looking, elementary level fraction operations. Then we started throwing in some algebra in there. And notice we had the same denominator, the same unit of measure. Remember this example, we had to remember to simplify, factor, and cancel, right? And we had the same unit of measure here. Now this one is where we started getting a little bit nutty, right? And I reiterated it's important to work on your practice. So make sure you are practicing the stuff on the assignments that I'm giving to you. And we did the same thing with 4B. So we got this far, and hopefully by now you have at least done a handful of these practice examples from the assignment on your own, because things are going to get a little bit weird. So now we're going to take the same concept that we have used in number 4, and in both A and B, and then we're going to start to apply it to polynomials. Okay, this is where stuff is going to get a little crazy. So when we look at example 5, we have these two rational expressions that we're going to be simplifying through addition or subtraction. And hopefully we notice right away that in example A, our denominators are not the same, right? So our denominators are totally not the same. We're going to have to somehow find a way to get the same denominator. So this is where I'm going to go back to our note, our original note for converting denominators. So we had two different denominators, right? B and D. And what did we do to find the same denominator? We multiplied this denominator by this one, bloop, bloop, and then this denominator by this one, bloop, bloop, and then we ended up with the same denominator, right? Funny how that works. And we're going to take that concept. And you can, by the way, you can always do that. You just might have more canceling. You're not going to necessarily have the least common of the denominators, but you will have a common denominator. So you can, by the way, you can always do that. Multiply this denominator by this, bloop, and then this denominator by this one, bloop, and then you'll always have the same denominators, not always the least common. Anyway, how does that apply to this example 5a? What? All right, so we have this denominator here. It's x plus 3, right? We have this denominator here, x minus 3. Clearly not the same. Not the same unit of measure, I say. So if we look at this first denominator, x plus 3, and we look at the second denominator, x minus 3, what is this first denominator missing, right? Well, first of all, let's consider each denominator as a group, okay? Consider each denominator as a group. That'd be a helpful thing. And if we consider each denominator as a group, what is the first number missing from the denominator if we're going to have a common denominator? It's missing x minus 3. So if only it needed an x minus 3 along with it, we'd be set. And then this denominator, what's it missing? It's missing x plus 3. So this denominator needs an x plus 3. And if we had that, boy, we would be laughing. We'd have the same denominators, right? So our first denominator needs an x minus 3. So what do we do with the numerator, right? Well, if we can't just up and multiply the denominator by thing. Maybe we have to multiply by a clever 1. Multiplying by 1 will not change the value of that number. And we can't just up and change the value of this number. So what do we have to do? We have to multiply the numerator by the same thing. Now this clever 1 turns into an awful, crazy 1. Look at that, crazy 1, right? So we can't just up and multiply the denominator. We have to multiply by a clever 1. So this first number needs an x minus 3 over an x minus 3. what does that mean for the second number? Well, the second number, it's missing that x minus 3. So if that second number had, or missing x plus 3. So if that second number had an x plus 3, now take a look at the denominators. X minus 3, x plus 3. X minus 3, x plus 3. What? Laughing. That's exactly what we need, right? Totally we need that denominator. But we can't just up and change this, this number. We have to multiply by a clever 1. That way we don't alter the value of the number. Okay, we're not altering the value. We're just multiplying by a clever 1. So, right, stuff got crazy. I'm telling you, if this makes no sense at all, if you don't understand what just happened, I guarantee you didn't watch that first video. So shame on you for not listening to me. Stop this now and go watch the previous one, part 1, okay? Otherwise, hang in there because it's going to get crazy. So now what we do is simplify our stuff. Right? The first number, now we're going to have 11 times x minus 3 in the numerator. And then in the denominator, x minus 3 times x plus 3. And then we're going to subtract that by this crazy thing. In the numerator, we have 3 times x plus 3. And that's over this crazy denominator, x minus 3 times x plus 3. Right? So this is what we have gotten to so far. Now, before you start canceling things, don't do that. We have to subtract first, right? So chill on the canceling. Right? You don't want to do that. We are adding and subtracting, not canceling. Okay? We're adding or subtracting, not canceling yet. So chill. Okay? Not canceling yet. You must chill. So if you cancel, then you would have undone what you did. So don't do that, right? Don't go circular on me. What we have to do now is recognize we have the same denominator, right? Now we're working in the same unit of measure. Now before I do anything with that same unit of measure, I want to simplify my numerators. Okay, so before I do anything else, let's go ahead and simplify the numerators. Okay, now how does that work, Mr. Katz? Well, you tell me. How do we simplify that numerator? If you say the distributive property, good for you. So we're going to simplify the numerators. 11x minus 33 in the first number. And I'm going to keep it factored. If you've recognized conjugates by now, good for you. But I'm going to keep it factored. And then minus, and then this numerator, 3x plus 9, right? So hopefully you saw that. And then that's going to stay over, again, keeping it factored. I'm chilling, right? So I have simplified my numerators. Now I'm going to work in my same unit of measure. The unit of measure is over all this, right? So I'm going to keep it over all this. And then how do I operate with that subtraction? Remember from the previous examples that we did on the other video, we have to be careful when we're subtracting. We want to subtract the entire numerator. And so we're going to do that. Let's be careful when we are subtracting. We're going to subtract the entire numerator. Now, I want you to see what I'm about to do because I need to start moving a little bit quicker than I normally do. So I'm going to have minus 3x. And I'm going to have minus positive 9, or minus 3x minus 9 in my numerator. Okay, so I was very cautious for that. Okay, so hopefully you were listening to me. By the way, I'm catching some students that are just watching and not listening. Cut that out, dude. You need 2 senses. Anyway, so we have our numerator. It's a little bit messy. Let's clean it up. The denominator stays the same. X minus 3, x plus 3. What's in the numerator? Okay, so we have 11x minus 3x. That gives us 8x. And then we have minus 3 minus 9. And minus 3 minus 9 is minus 12. Okay, so before we say we're done, and we are, by the way, but before we say that, let's see if we can factor and cancel, right? Let's look to simplify. Can we factor and cancel? Right, so you want to keep that in mind. Can we factor and cancel? And when you look at that numerator, yeah, we can factor it. Right, the GCF between 8x and 12 is 4. Right, so can we factor it out? We have 2x minus 3. you know what, we could factor it, but nothing would cancel. We get 2x minus 3, x minus 3 doesn't cancel. So we could factor it, but we wouldn't cancel anything. So I don't care how you write it, right? I'm actually cool with this. This is a little bit nutty, but we have subtracted the original thing, right? So you remember we had x plus 3, x minus 3. Blam. There we go. So that was 5a. Notice things are getting crazy with our denominators. So now in the next example, if you didn't copy it down before, 5b, let's see something a little bit different. And this will also be a blast from previous lessons. Now we have these two denominators. Clearly not the same, right? But what can we do with this, right? Do you remember from simplifying rational expressions, so from the previous video, there's something funny about these denominators, right? We can't just up and switch it. We cannot call this one this, we can't call this one that. But we can't do that because subtraction doesn't work that way. However, if you recall from the previous video, in the previous lessons on simplifying rational expressions, if we could factor out a -1 from one of these, it would totally look the same. So you know what, we can do that. I'm going to factor out a -1 from here. If I factor out a -1, I have -3 plus x, which is also -1 times x minus 3, right? So check this out. Check this out. I'm actually looking at the following addition problem. I'd have y over x minus 3 plus 4 over -1 times x minus 3. So it's almost the same denominator. It's just that -1. Now, 1s are so much fun. Some of you are going to want to multiply this one by -1 and do this. There's so many correct ways to do this. But what I'm going to do is simple. I'm just going to move my -1 up to the numerator. That's right. You heard that correct. That's the beauty of 1. I can do that. So you can multiply this, right, if you wanted to. Multiply this one by -1 and multiply this one by -1. You can do that, right? And that's going to be just fine. But what I'd rather do is see that I'd have y over x minus 3 minus 4 over x minus 3. That's right. -1s are so much fun to work with. And you're going to say, Mr. Katz, how? Man, that's not fair. You lost me, right? No, I didn't. Dude, you know this. Take a look at an example. What's 4 divided by -4? You know 4 divided by -4 is -1. Does it matter where the negative is? No, it's still going to be minus. What's -4 divided by +4? It's still going to be -1. Right? So -1s are fun. The -1 could be in the numerator or the denominator. It doesn't matter, right? Because -1s are fun to work with. So I'm just going to go ahead and move it to the numerator. That's just a neat trick that you can deal with. Anyway, now that I've worked with that trick, denominators are the same. Boom, bam. And what's left in my numerator? Y minus 4. That is all I can do. Y minus 4 over x minus 3. I can't cancel anything. Can't factor anything. Must be done. So example 5b just shows some more neat stuff with -1. 1 is such a fun number. We underestimate it constantly. All right, now before we get into problem number 6, let's take a look at problem number 6. We're going to have to do a whole lot of factoring for problems 6, 7, and 8. So before we get into that, I'm going to show you another crazy denominator example. Take a step back. Now remember we were talking about addition. If the denominators are the same, let's operate. If the denominators are not the same, let's find the same denominator. But I want to go a little bit crazier. Let's go a little bit crazier. What if we had some crazy looking denominators? What if I wanted to add all three of these? BC is the denominator, right? So over BC, over ED, and over BE, right? So how in the world am I going to find a common denominator? Well, this is BC, this is ED, this is BE. You know what all the denominators have? They have a B, a C, a D, and an E, right? They all have B, C, D, E. So the common denominator of all three of these fractions is B, C, D, and E. That would be the common denominator of all four of these. This has a BC, this has an ED. So if I put them together, they'd have the same thing, right? So the first thing is recognizing what would be the common denominator. And like I said, that was the shortcut from before. If I multiply this by the thing, bloop, and the thing from the thing, bloop, it's the same concept, right? So this common denominator, B, C, D, E, that's hard to see. And so hopefully you understand that. If you don't, we're going to pause here. I want you to pause here and then take a breath and then get back. All right, so if that's our common denominator, what would that mean for adding this? This is what that would mean. Our first number in the denominator, if we have BC, you know what it's missing? It's missing a DE. So it's missing a DE. I can multiply that. Our second number has an ED in the denominator. It's missing a BC, so I can multiply it by that. Our third number has a BE. It's missing a C and a D, so I can multiply it by that. But I multiply it by clever ones. So it's the same concept. I'm just making it a little crazier. Why I titled it a little bit crazier. So now I multiply my clever ones, right? I'd have A times D times E. Boom. C times C is C squared times B. Boom. Should have been alphabetic, but I guess I kept it in descending order. And then G times C times D. Boom. All of that is now over the common denominator, BCDE. 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 Ta-da! So that's just another a crazier example of what can happen with common denominators. Now, why would I bring that up? Take a look at number 6. That's why I would start to bring that up, right? How can I tell what these denominators are missing, right? I can't tell what these denominators are missing from one another because they're not showing multiplication, right? So, darn this denominator. I don't know what I'm missing from this number to have, I don't know what I'm missing in my denominators. I can't tell because they're not factored. If I could factor my denominators, everything would be so much easier. So factor the denominators to see what's missing. Okay, that's going to be an important note. Factor the denominators to see what is missing. Such a neat note. Okay, so in the first number, my numerator stays the same. What's the deal with my denominator? Can I factor this denominator? Yes, I can. You best recognize that is a difference of squares. Therefore, it factors into conjugates. Okay, so I factored my first denominator. Now I'm going to keep the sign the same for now. And then in my second denominator, I got to factor that. Okay, so I have k squared plus k minus 2, mental math, x factor, factor by grouping, do whatever you got to do to realize that this denominator, when I factor it, is k plus 2 times k minus 1. Now I have factored my denominators. Okay, so believe it or not, what you see here is exactly like 4a. One of the last examples from the previous lesson. This is exactly the same step we're at. We're not at anything different than that. Okay, so I need you to chill out on freaking out because we're in the same place we've been before. We have two different denominators. What does this denominator have that this one doesn't? And what does this denominator have that this one doesn't? Right? So this first denominator over here, it's got a k minus 2, k plus 2. What's missing? It's missing a k minus 1. So this needs a k minus 1. What does this denominator have? And then what's it missing? This denominator, it has these two. It's missing k minus 2. So I can say, well, this one needs k minus 2. And then we would have the same denominators. We would have k minus 2, k plus 2, k minus 1. We would have the same denominator if we just recognize that. Right? But we can't just up and add those things to the denominators. We have to multiply our clever ones. So we multiply by our clever 1. I don't know why I did a double parenthesis there. It doesn't make any sense. So if this first number needed a k minus 1 in the denominator, I multiply by my clever 1, not changing the value. And in my second number, the denominator needed a k minus 2. And I can't just up multiply that. I have to multiply by a clever 1. So in the numerator, k minus 2. Right? So I got this crazy thing going on. So I want to simplify stuff, okay? So this is going to be a little weird. You might have to pause and rewind a couple times. And if you do that, I don't care. I actually would love to hear from you when you say, you know, Mr. Katz, I paused and rewound a couple times, and it totally helped. And I would say, thank you. Thanks for listening. Good stuff. So now, in the numerator, I'm going to simplify. K times 5k is 5k squared. Minus 1 times 5k is minus 5k. I've just distributed. Bloop, 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 bloop. In the denominator, I'm going to leave the denominator factored. I've already quizzed you on multiplying crazy stuff like this, right? Remember challenge 8? Oh yeah. So I've just cleaned up everything a little bit. I'm going to do the same thing over here. I'm going to simplify my numerators. 2 times k, 2k, and then 2 times minus 2 is minus 4. I'm going to keep that simplified. And that's over the same denominator. I got a k minus 1, a k minus 2, and a k plus 2. K minus 1, k minus 2, k plus 2. Okay, so everything that we've done so far has been the same, right? Totally been the same. And so now, what were we doing with these two things? We were subtracting. Okay. So now what I'm going to do, I have my common denominator. That crazy denominator is totally common. By the way, do you believe me now that addition is not as easy as multiplication? Hopefully you do. All right, so I have my common denominator, and I know you're thinking, wait, Mr. Katz, it's the same thing, dude. Commutative property of multiplication. Chill out. I didn't want to erase my plus. So there's that. My denominator is the same. All I have to do now is simplify my numerators. So I have 5k squared minus 5k. And remember from previous examples, we have to be careful. So we're going to subtract the entire denominator. Okay, we have to be careful. We're going to subtract the entire denominator. Okay, so we got to be careful there. Please be careful. Do your homework, right? Make sure you're practicing this stuff. You guys, I don't know if anyone can watch this and say, oh, I got it. No, you have to practice. So let's simplify our numerator. Denominator stays the same. You know what? I'm going to mess with your heads. I'm going to change it again for you. Mr. Katz, stop it. It's all multiplication. I don't care. You should get comfortable with that. So now we're going to simplify the numerator. We get 5k squared. Combine like terms. Minus 5k minus 2k is minus 7k. And then plus 4. Now I know what you're thinking. I know what you're thinking. Are we done? Maybe. We don't know if we're done. Right? Are we done? Maybe. Are we done? Maybe. How can we tell? Right? How can we tell? Can we factor the numerator? Can we factor the numerator? All right, so how would we be able to tell if we can factor the numerator? Well, we got to remember a times c, right? So a times c, 5 times 4 is 20. Are there any things that we can multiply together to give us 20? When we add them, we get negative 7. Okay, so we got 1 and 20, no. 2 and 10, no. 4 and 5, no. No. So we can't factor that numerator, so we're done, right? Can we factor it? No, so we're done. Holy cow. You mean to tell me, Mr. Katz, that is the resulting expression? Yes. You start with this, you start with our crazy subtraction piece, you get this for a result, okay? And the whole thing is about finding the missing elements of the common denominators. And so that was example 6. Now let's do example 7. And let me tell you what, if you don't remember factoring, pause here, go back to the previous unit, make sure you know how to factor. All right, so example 7. This is going to get nuts. So make sure you're aware and paying attention and pausing as you have to and going back to previous videos as you have to and emailing me questions as you have to and all that stuff. So we look at number 7. Can I tell what's missing from our denominators? No. I can't tell what's missing from our denominators. We're going to have to factor the denominators so we can see what's missing. Factor the denominators so we can see what's missing. Okay? That's going to be so important. So we factor our denominators. We're going to see what's missing. Okay, so in this denominator, a times c is negative 6, right? So I have 3x squared, blank x, minus 2. I'm going to factor this by grouping. A times c is negative 6. What two numbers multiply to negative 6 yet add to negative 5? That is going to be negative 6 and positive 1. And then when we factor by grouping, we're going to end up with 3x as the GCF, and then x minus 2, and then plus 1 is the GCF, and then x minus 2. So this denominator, as a matter of fact, is x minus 2 times 3x plus 1. All right, so that is actually our denominator from the first number. Okay, so from the first number, our denominator is factored, and now we're going to factor our second denominator. And again, I'll do by grouping. 6x squared, blank, minus 5. AC is negative 30. What two numbers multiply to negative 30 yet add to negative 13? Now, if your original guess is 3 and 10, you better check yourself before you wreck yourself, because we're dealing with a negative 30. That means one of the numbers is positive, the other is negative. So before you jump into 10 and 3, chill out. This is a negative 30. So we have to deal with 15 and 2, ladies and gentlemen. Minus 15, positive 2. Okay, so you have to be careful on that factoring step, okay? Check yourself before you wreck yourself. Now, we factor by grouping. GCF of the first two is 3x. We will be left with 2x minus 5. GCF of the next two is positive 1. We'll be left with 2x minus 5. And now we have our factored denominator. 2x minus 5 and 3x plus 1. Okay, so our second number with the factored denominator looks like this. Okay, so we have factored our denominators first. Now hopefully you can clearly see what's missing from each denominator. Clearly not the same denominator. They both have 3x plus 1. That's handy, right? But the second number has the 2x minus 5. This one doesn't. And the first number has the x minus 2. This one doesn't. So if we're going to do that whole multiplication trick shortcut, what does this first one need? This first denominator needs a 2x minus 5. And we can't just up and multiply that. We have to multiply the numerator by 2x minus 5. Okay, so we have to be cautious again with that giant 1. What about the second denominator? What's it missing that the first one has? X minus 2. So this one needs an x minus 2. So we'll multiply the numerator by x minus 2. Okay? Okay. So now, this is where stuff gets fun. Make sure you're listening. I'm going to write this down in case you're not. Listen. Did you hear that? Okay, so now listen. Now we're going to do, we have the same denominators. What I'm going to do is multiply the numerators so I can simplify them, because you never know what type of neat stuff might happen. So my denominators are going to be the same. What's going to be in the numerators? You're listening? I'm going to multiply the entire numerator. I'm not just distributing the 3. I am multiplying 2x minus 5 by the entire numerator. Group, folks. So I'm multiplying by the entire numerator. So when I multiply these two factors, I have 4x squared minus 10x plus 6x minus 10x plus 6x, which is minus 4x. and then minus 15. Okay, so I have that numerator. Now for my second number, my denominators are the same. It's x minus 2, 3x plus 1, and 2x minus 5. I now have common denominators, yay! But I'm going to do the same thing. I'm going to multiply the entire numerator. I'm going to multiply the entire numerator. All right, so I have x squared, okay, x squared, minus 2x minus 6x. Minus 2x minus 6x is minus 8x, and then plus 12. Okay, so I've done some neat things, right? So now I have my two numbers with the same denominator. I'm going to keep it the same. So I have my x minus 2, 3x plus 1, 2x minus 5. So you might be thinking, Mr. Katz, why multiply the numerators but not the denominators? Because I'm going to be combining like terms. That's why. Okay, I'll be combining like terms up here. So I'm just now adding 4x squared plus x squared. 4x squared plus x squared is 5x squared. Minus 4x plus a negative 8x is a negative 12x. And then minus 15 plus positive 12 is a minus 3. And you might be thinking, are we done yet? Okay, so are we done? So we have factored and we have combined like terms. We've done all sorts of stuff. Are we done? We don't know. Are we done? Maybe. All right. Can we factor the numerator? All right. Can we factor the numerator? Well, what's a times c? A times c is negative 15. Right? Are there any factors of negative 15 that add to give me negative 12? And let's see, well, we got 1 and 15, no. We got 3 and 5, no. So we're done. We can't factor the numerator, so we are done. But you know what? There might be a time when we could have factored the numerator. We could start canceling some stuff out, so be on the lookout. All right, so that is as done as we can get it. Okay? Now, let's see if you can keep up. I'm going to do the last example pretty fast. All right, so let's see if you can keep up. So for number 8, this is going to be super duper fast. I'm running out of time, and I want to show you how it's done. All right, so number 8, we get 2 over x minus 2 plus 3x over x squared minus x minus 2 minus 1 over x plus 1. Okay, so I'm going to go pretty fast. The first thing I'm going to do is factor my middle denominator. Okay, so I'm going to factor my middle denominator. Let's see if you can catch up, right? So I factored my middle denominator, and you know what I got in that middle denominator? The common denominator. So you can see here by looking at these three things, that middle denominator is what's going to be in common. This first denominator, the first number is missing x plus 1. The third denominator is missing x minus 2. So watch what's going to happen. I'm going to multiply this by x plus 1. So I get 2x plus 2 over the common denominator, x minus 2, x plus 1. The middle number remains the same. And the third number is missing an x minus 2. So I'm going to multiply that by x minus 2. And then I'll have x minus 2 in the numerator. But don't forget, I am subtracting it over our common denominator. Okay, so you can see I'm moving a little bit quicker. All right, so now I'm going to take all of these and put them together. So 2x plus 2 plus 3 minus x plus 2, all of that over our common denominator. All right, so look how fast I'm able to do it. You got to keep track of stuff, though. Now I can combine like terms. 2x minus x is x. Plus 2 plus 3 is 5. 5 plus 2 is 7. So x plus 7 is what I have left in the numerator. All over x minus 2, x plus 1. Ta-da! So that's you can start going fast if you see what's going on. But you can only do that with practice, practice, practice. For those of you that put your music back on, shame on you. I'll tell by your assessments. Practice, practice, practice. And that is it. Thanks for your patience. Peace out. Let's do this.